Hey, it's Mr. Luneski here with Unit 2, Section 1. Today we're talking all about different types of angle relationships or pairs of angles. We're going to talk about certain ways to classify angles. So we do have some vocabulary. Some vocabulary may seem a bit familiar to you. So at this time, please pause the video and just go ahead and copy these definitions down. Okay, welcome back. So, in this figure we have three lines, line A, line B, and line C. Line C is referred to as a transversal. A transversal is any time that you have a line that is cutting through two or more lines. So we're going to be talking a lot about transversals today. And actually in this entire unit. This whole unit is all about angle relationships. So we're going to talk about some different types of angles here. We have interior angles. So in my figure, interior angles are just angles that are occurring sort of between the lines or inside the lines. So that would actually be these four angles here because they're sort of sandwiched between line A and line B. So my interior angles would be angle 3, angle 2, angle 8, and angle 5. Exterior angles are kind of the same concept, except that those angles go on the outside of the lines. There's not in between the two lines. So those would be angle 1, angle 4, angle 6, and angle 7. Now down here, these words that we are going to discuss right here, these are our angle relationships. When we kind of can say these two angles are this type of angle. So the first angle relationship we're going to discuss are consecutive interior angles. Sometimes you may hear them being referred to as same side interior. And if you think about the word same side interior, the definition just says that they are interior angles on the same side of the line. So earlier we mentioned that these ones were my interior angles. So remember, C is my transversal. So we want the two angles that are on the same side of the transversal. So the transversal is sort of broken up into the top part and the bottom part. So we could say that angle 3 and angle 8 are same side interiors or consecutive interiors. We also could say that angle 2 and angle 5 have that same relationship. Next angle relationship is alternate interior angles. So once again, we're working with interior angles, and it's sort of just the opposite of same side interiors. They're alternate interiors. They're on alternating sides of the transversal. Notice too that the relationship kind of hops between the two lines. So angle 2 and angle 8. 2 is sort of associated with line A and line C, and then 8 is associated with line C and line B. So they're on alternating sides of that transversal. So I could say angle 2 and angle 8, and I could also say angle 3 and angle 5. Alternate exteriors, kind of the same concept. It is exterior angles. So these four here that are on alternating sides of the transversal. So angle 4, again with A and C, and then we want to jump over to talk about something that's going on with B and C. So 4 and 6 would be considered a pair of alternate exterior angles along with angle 1 and angle 7. Corresponding angles are angles that are in the same position. I often refer to, when the lines cross each other, I refer to this as the four corners. So in this diagram we have two parts that are four corners. So each set of four corners is broken up into four positions. We have the top left, the top right, the bottom left. So corresponding angles are when one set of four corners matches the positions of another set of four corners. So there's actually a lot of sets of corresponding angles here. So angle 4 is in the top left position, and over here in this set of four corners, angle 8 is in the top left position. So we would say that angle 4 and angle 8 are corresponding angles. We could also use 3 and 7 because they're in the top right. We could use 1 and 5 because those are in the bottom left, and we can use 2 and 6 because those are in the bottom right. Vertical angles, we already discussed that back in Unit 1, but just as a friendly reminder, when you're looking for vertical angles, you want to look for that X shape. And as a reminder that vertical angles are congruent, which mean they have the same measurement. So if I look at this figure, we could say here's sort of my X or my T. So we could say that 1 and 3 are vertical angles. We could also say 2 and 4. We could say 8 and 6. And we could say 5 and 7. So those are all of our angle relationships. So let's just take a look at some practice problems here and see what this looks like. It says, given the figure, classify each pair of angles. So now we have 3 lines and then line P. So this is again acting as my transversal. So the relationship between angles 1 and 3. So notice I'm not really worried about these right now. I'm just focused on 1 and 3. So if I take these 4 corners and these 4 corners and almost pick it up and lay it on top of each other, 1 and 3 match positions, so those would be corresponding angles. The next problem is what's the relationship between 1 and 10? So 1 is here, 10 is here. Again, I'm not worried about these angles right now. I'm only focused on this set and this set. So what's the relationship between 1 and 10? Those are alternate exterior. They're on opposite sides of the transversal, and they're considered exterior to line L and line M. The relationship between 2 and 9. So 2 is here, 9 is here. Again, not worried about any of those 4 angles. So if I'm looking at this, these would be alternate interior because they are on alternating sides of the transversal, and they are considered interior angles. If I look at 10 and 5, so 10 is here, 5 is here, so now I'm not using these angles. This one on opposite sides or alternating sides of the transversal, and they're considered interior angles. One thing I would like to point out on this problem is notice we had angle 10 in this and angle 10 in this. In problem number 2, angle 10 was considered an exterior angle, and in problem 4, angle 10 was considered an interior angle. So when you're dealing with multiple lines, in this case we have 3 lines, they can sort of fluctuate in terms of are they interior or exterior. When we're comparing angle 10 to this line, it's exterior. But when we're comparing angle 10 to this line, now it's interior. So just make sure you're paying attention to stuff like that. We have angle 12 and angle 7. So this one's kind of a tricky question. They have no relationship. We can call them exterior angles, but more importantly, there is no relationship between those. There's no such thing as a same side exterior. So if something like that were to come up, you're better off just telling us that there's no relationship between those angles. Angle 11 and angle 6, that's kind of our callback from Unit 1. Those are vertical angles, because again, we're really not paying attention to any of this, not paying attention to any of this. We're contained right inside these 4 corners. So there's my X. Those are vertical. And finally, the last one here, we have 1 and 12. So here's 1, here's 12. Good old alternate exteriors. Alright, so now we're going to look at what are known as the sort of the angle relationship postulates and theorems. There are 4 of them that you need to know. A postulate or a theorem are just things that have been proven mathematically that we're allowed to use in classes. Theorems have been proven. Postulates have not been proven. So it's just something that's sort of mathematically accepted. Corresponding angle postulate says if two parallel lines are cut by a transversal, then each pair of corresponding angle is congruent. And remember, congruent just means that they have the same measurement, that they are equal. The key to this is that the lines have to be parallel. So in the examples that we were just looking at, the lines were not parallel, or we weren't told they were parallel, so we couldn't claim that the corresponding angles were equal. Alternate interior angle theorem states that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Consecutive interior angle theorem states if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. And just as a reminder, supplementary means they add up to equal 180 degrees. Alternate exterior angle theorem states if two parallel lines are cut by a transversal, each pair of alternate exterior angle is congruent. So, rather than trying to go through and memorize all of that terminology, I kind of summarized all of that into this little chart, which I think is extremely helpful. As a reminder though, in order for these things to be true, the lines must be parallel, and that's the really, really important part from this section today. So we sort of have two scenarios that are happening. We're either going to set things equal to each other, or we're going to add them together and set them equal to 180. So here's a list of the relationships that if the lines are parallel, we can set them equal to each other. Corresponding angles, alternate interior, alternate exterior, and just as a friendly reminder, vertical angles. Now the reason that I wrote that one in red is because the lines don't need to be parallel in order for this to be true. All vertical angles are always going to be congruent, regardless if the lines are parallel or not. And then which set of relationships are going to be supplementary? In other words, we're going to add together and set equal to 180. That would be our same side interiors or consecutive interiors. And again, in red here we have linear pairs. So linear pairs, as a reminder, always add up to 180, but the lines don't necessarily need to be parallel in order for this to be true. So how do we apply this information to problems? Let's take a look at our two examples here. So in our first problem, we are told that the measure of angle 5 is 2x minus 10, and we are told that the measure of angle 7 is x plus 15. So what you want to do is sort of pinpoint what angles you are looking at, and then identify which angle relationship those things are. So if I look here, I'm mainly focused on this set of four corners and this set of four corners. This stuff over here really isn't helpful for me right now. So angle 5 and angle 7 are in the same position. Bottom left corner, bottom left corner. So those are corresponding angles. So how do I go about solving this? I'm going to set these things equal to each other. So the two expressions that we are given, 2x minus 10, we can set that equal to x plus 15. And now we just use a little bit of algebra and we solve for x. And the problem here just states to find x, so we really don't need to go back and substitute anywhere in particular. So the answer for that is x equals 25. Alright, and then our last problem here says that if the measure of angle 1 is 9x plus 6, and the measure of angle 2 is 10x minus 6, and measure of angle 3 is 3y plus 14, find the measure of x and find the measure of y. So, if you notice, we have a y here, and we have two x's. So most likely we're going to do something with these two x's, because we can't solve if we're just doing an x and a y. So I want to look at what's the relationship between angle 1 and angle 2. Based on my diagram here, notice these arrows here. I forgot to mention this in the first problem. These arrows indicate that the lines are parallel. So in this problem, line A is parallel to line B, line C is parallel to line D. So in this problem, angle 1 and angle 2 are alternate exteriors. So how do we solve this? We set them equal to each other. So down here, we will do 9x plus 6 is equal to 10x minus 6. Now when I substitute, or I'm sorry, subtract 9, add 6, we get an answer of x is equal to 12. So now we need to go and solve for y. So y is down in angle 3, right here. So now we need to figure out, well, what's the relationship between angle 3 and angle 2? And I'm not really going to use angle 1 here because angle 3 is with line D and line B, and angle 1 is with line A and line C. So they're on totally different line sets, whereas line 2 and line 3 are sharing B as a transversal. So the relationship between 3 and 2 is that they're corresponding. So that means I can set angle 2 equal to angle 3. So that would be 10x, but we know now that x is 12. And we can set that equal to 5y plus 14. So now we can go through and solve this problem. So 10 times 12 gives me 120. When we simplify this, we get 114 equals 5y plus 14. Subtract 14 from both sides, we get 100 equals 5y. And when we divide both sides by 5, we get y is equal to 20. Alright, that is it. Thank you for watching.